Today we'll be seeing this memory hierarchy in computer systems. We'll understand the layers of data storage. First one is what exactly is memory hierarchy. Well, memory hierarchy is a computer architecture concept that organizes different types of memories, ranging from high-speed, low-capacity register and cache to slower but larger main memory and secondary storage devices in a hierarchy structure. This arrangement optimizes data access time, cost effectiveness, and storage capacity for the effective computer operations. Now, what exactly is importance of memory hierarchy in our computer systems? Computer system needs a hierarchy. Uh, we'll understand the reasons after seeing my PPT. The importance of memory hierarchy in computer systems cannot be overstated. It plays a vital role It plays a vital role in enhancing system performance, improving efficiency, and balancing the trade-offs between speed, cost, and capacity. Here are the several key reasons why memory hierarchy is crucial. First of all, speed and effectiveness. We need how memory hierarchy can decide where to optimize the speed and where the effectiveness can be reached at the most cost effective storage which storage is needed regularly and which storage is needed just a few times. Capacity management, power efficiency, power efficiency. For example, your um, laptop, if the memory hierarchy is very good, then the capacity of the device can be optimized, and the power will be less, will not be will be saved a lot, and it can run for a long time. Reduce latency, scalability, and catch coherency. Now let's move to the next steps. What are the types of memories? Well, if you look for types of memories, there are four types mainly: register, cache memory, main memory, and secondary storage. Let's look at register. Registers are the smallest and fastest type of memory located within the CPU, which is central processing unit, as everyone knows. They are used to store a small amount of data, inscriptions that are actively being processed by the CPU. They use very small amount of data and instructions. They can't handle too big of data size. Register have very limited storage. As you see, the registers are very fast, so they had to have some setbacks. uh, if not, then we'll all use registers in our computers. The setback is that it has very limited storage, and it is typically measured in bytes. The speed. Now, if you look at the speed, registers are the fastest memory in the computer system, offering almost instantaneous access time. As we have discussed before in the description, that the speed is very just the fastest in the entire hierarchy. It comes at the top. Now, what are the purposes of register? Registers are used for rapid data manipulation and execution of CPU instruction. They play crucial role in speeding up the program execution. There are times when computer needs that instant execution of a program, and they can delay some important things. Like you are in the stock market and you are buying a stock, you have to be precise at times, and that's when you can delay a few seconds also. So they are used for this purposes generally, where instant speed is required. Now, what is cache memory? Cache memory, let's look at the description. Cache memory is a type of high speed volatile memory located between CPU and the main memory, which we call it RAM. It stores frequently used data and instruction to reduce memory access time. Generally, what happens is as we said, resistors. Resistors are inside the CPU, and RAM is outside, a bit out. So the cache memory is right between them, and it actually looks after the most recently used memory, and so it directly connects to the register. So um, directly connects to this CPU, so it doesn't have to go to the RAM, and it still gives a faster speed than it has to go to the RAM. It stores frequently used. So it is usually stores the data that you have frequently used and reduce the memory access time. The size. Cache memory comes in multiple levels, with L1 level 1 being the smallest and the fastest. L3 level 3 be larger but slower than L1 and L2 caches. So as we already know that larger memory means it has basically affect to the speed of the memory access point. So speed cache memory is faster than main memory but slower than register. Main memory like RAM, it is faster than it, but at the same point of time it is slower than registers. Purpose. So the purpose cache memory minimizes CPU waiting time by providing quick access to frequently used data, improving system performance. Like you have just opened a app and you just closed it by mistake, and then you open it again, though the response will be fast because the cache memory has already stored it and it has not gone back to the RAM, so it can access it very quickly and send it to it. Now, what is main memory? Main memory, as we generally know, RAM. Description everybody already knows. RAM is a primary working memory in the computer system. It holds data and instructions that are currently in the use by the CPU and software application. What is the size of sizes? The size of the RAM we know is very wide, very from few gigabytes in the consumer computers to terabytes in high-end servers. Speed RAM is faster than secondary storage but slower than cache memory. As we all know, a secondary storage is way outside, so it takes a lot of time to connect it to the CPU. So, purpose. RAM provides a compromise between speed and capacity. It is a kind of compromise because we don't have that much cache memory or registers. So we have come with a compromise to solve this. A RAM provides a compromise between speed, ensuring that data required for immediate process is readily available to the CPU. The data is required and it needs fast data. So RAM has the data that needs a little bit of time, but still within the reasonable amount of time. It gives you the data that the computer needs an access to. Now, secondary storage. So this is the storage where external devices like hard disks, pen drives. These are all secondary devices. Secondary, let's look at the description. Secondary storage consists of non-volatile memory devices, including hard disk and solid-state drives. It is used for long-term data storage and retrieval size. Secondary storage devices have much larger storage capacity than RAM, often measured in terabytes or more. Speed, while SSDs are significantly faster than traditional HDDs, both are considerably slower than RAM. SSD we know is quite costly than the regular hard disk, but it actually gives you an advantage in the speed. It is slightly faster than hard disks, but still they are both considerably slower than RAM. Purpose: the secondary storage is used for storing the operating system, application software, user data, and other files that need to be retained when computer is turned off. It provides long-term storage and is crucial for data backup and archival process. It can be used as a data backup. We can just take it out and put it in another computer. We get all the data back. but it's quite hard to take out a RAM and connect it to other RAM, and it's quite difficult. And cache memory is almost impossible to do. Cache memory. Cache memory is a special type of high-speed volatile located between registers and RAM, as we have already discussed. Role of cache memory. Cache memory is crucial component for improving system performance by reducing data access time for frequency and use instruction and data. It acts as a buffer between high-speed, low-capacity register and slower but larger main memory. Levels of cache. Cache memory is structured into multiple levels, typically denoted as L1, L2, L3, and sometimes L3. Okay. Each cache memory varies in speed and capacity, while L1 being the smallest but fastest, L3 offers larger capacity at slightly slower speed compared to L1. Now, catch hits versus catch miss. Catch hit refers to a situation where a requested data is found in cache, resulting in a rapid retrieval. Catch miss occurs when the data is not present in the cache, necessitating retrieval from the slower main memory. Cache hit rates are essential for enhancing the performance. As we know that the cache main objective of cache memory is to have the recently used data and to have the user use that data which is in the cache memory itself. So we need to have that kind of mindset and need to understand the uses of the user, that what user usually uses frequently, to make sure that the cache memory has the certain data that the user will frequently use. So if we can get that data to understand the user and make sure the data is in the cache, then it will be frequently it will be faster. But if the cache memory doesn't have the data that user uses, then the use of cache memory will become uh, non-existent in itself, because the data that user is trying to retrieve will not be found in the cache memory itself. So cache hits are very essential for good performance of the computer. Cache size and associativity. Cache design includes consideration of cache size and associativity. Cache size determines the amount of data that can be stored in cache. Associativity defines how data is mapped within the cache, with options such as direct one way, set access n way, and full associativity. Use case. Consider providing a practical example or real world. For instance, now let me show you something. Real world examples. To understand real impact of memory hierarchy, let's explore how it's applied on everyday technology. First, let's look at smartphones. In smartphones, memory hierarchy is vital. Multi-core processors and cache memory ensure the responsive performance. Cache memory is very widely used in mobile phones, because they don't have that big of memory. They need quick responses. You can have slow responses because it doesn't have the power of a entire computer. CPU is small. The multi-core processor have limited power, so it needs cache memory to be very powerful, very responsive. RAM handles multitasking and app performance. Secondary storage such as NAND flash provides ample storage for apps and data. Game console. Game console relies on memory hierarchy for high performance gaming experience. Cache memory L1, L2, etc. enhances the frame rates and gameplay. RAM stores game assets for quick loading, and SSDs offer fast gaming instruments. So that is it for this explanation of mine on the memory hierarchy in computer systems. My name is Yash Patel. I am my ID. I am studying in CHARUSAT University, Computer Science, and my ID is 22CS068. This presentation I'm going to submit in my as my assignment to my professor Harshul Yagnik. Okay, so that's it. I'm stopping it.